In this example, we're given that triangle ABC is similar to triangle DEF, and we're asked to find the measurement of the unknown sides. Here are our triangles. In triangle ABC, we have all three sides and their measurements indicated, as well as two angles. In this triangle, DEF, we have the two angles identified and the side. We are missing two of the sides, however. So we need to go back to a property that in similar triangles the corresponding sides are in proportion or are proportional, which means that we can set up our ratios of side AB compared to side DE should be equal to the ratio of BC compared to EF, which should be equal to AC to DF. Now we can substitute in some numbers that are given in the illustration. So we know that side AB is 5.65 and side DE in the diagram here has been renamed to be lowercase f because it's across from angle F. So typically we like to refer to that as the lowercase version of that vertex. So we'll call that side F. And in the next ratio, we know that BC is 6.13 centimeters, and that side EF, which was an unknown, will again use the lowercase version of the vertex that it's across from, so we'll call it letter lowercase d. And the third ratio is side AC, which we know is 5 centimeters, to DF, which again was given as 8. So we've set up our proportion, and now we can solve for the two unknowns by splitting this proportion up into sections that we can use. First part that we're going to use is compare the 5.65 to F to the 5/8, the ratio that we know for sure. And we can cross multiply to try and solve for F, giving you 5 times F is 5F, and 5.65 times 8 looking something like this. If we simplify this, we get 5F equals 45.2, and we need to isolate F by dividing both sides by 5, giving you F equals 9.04 centimeters. For the second unknown, we can consider these two sections of the proportion. So we'll do 6.13 divided by d equal to 5/8, which is again the fixed ratio that we know in this proportion. We'll cross multiply again, giving you 5 times d is 5d, and the 6.13 times 8 illustrated here. Simplifying this, you get 5d equals 49.04. And when you divide both sides by 5, again the number in front of d to isolate it, you get d equals 9.808. Or we could round that to be about 9.8 centimeters. So we can say that side F, which we know to be DE originally in the diagram, is 9.04 centimeters long, and side D, which we originally illustrated as being side length EF, is approximately 9.8 centimeters long.